Hello everyone, I'm Silvia Rossi, a PhD student at UCL. Thank you for the presentation. And today I'm talking about adaptive streaming for immersive communication. And it's a bit different than the previous presentation because it's more focused on the user side. In particular, I would like to start with an introduction about 360-degree video streaming, where I'll point out the main challenge that we can find to improve this kind of application. And finally, I want to give you some ideas, some strategy that I've already implemented to overcome these challenges, and something that I'm working on now. So, let's start. We have already talked about virtual reality today, and in very simple words, I want to explain what is virtual reality. So the main novelty of this application is the full immersion sensation that is given to the user. So the user believes to be really inside a new world that is not anymore physical, but it's virtual. And how we can get this full immersion sensation? It's thanks to the 360-degree video or omnidirectional video. That is a new multimedia content where the scene is fully recorded. So basically, this kind of video has more information recorded because the user that is supposed to be in the center of the sphere, changing his head position can change the part that is displaying. This part is called viewport. As we can see, is just a small part of the entire sphere. So obviously, this kind of video has to deliver to the user. So here I want to show you the general 360-degree video streaming change. The first step, as in a traditional streaming, is the part that regards the video editing and shooting. And the result this time is, so here we have the sphere signal is the result of the video editing, and the novelty at the content provider is that the sphere has to be projected on the planar, because with the nowadays technology we can't store and deliver a spherical signal. So as we'll see later in the presentation, this is a new challenge that has to be overcome. At the same time, at the user side, we have a new part that is the viewport extraction, because the user downloads the entire video, but obviously it has to display only a small portion that depends on his position on the sphere. Traditional now is very popular, the adaptive streaming over internet, over HTTP. But here we have a new degree of freedom that is always, again, the position inside the sphere. So it has to be developed a navigation-based adaptive logic to try to figure out what is the best representation to download based on the user position inside the sphere and based on the available bandwidth. So I've already tried to give you some idea of this new challenge, and here we can see better that the new challenges are related to the spherical signal, but also now we have a huge volume of data that has to be stored, delivered, and finally displayed at the user side. And obviously, since the user has to have a very immersion sensation, this application is ultra low delay, but we don't have to forget about the limitation in terms of bandwidth. And finally, the main problem is related to the fact that we don't know a priori where the user is going to look at inside the video. So we can sum up this problem with the three fundamental key questions that are: how can we consider the geometrical aspect in the quality, which content has to be stored and then delivered to the user based on his navigation path inside the video. So we can see that the key that connects all these questions is the user. So we can talk about a user-centric area. So about the first question, it's about the quality. It's a very old problem because it's the same problem that we had when we want to project the globe in a map, so in a planar way. And obviously, the equirectangular projection is the most popular and simplest projection that can do that. But we have some problem. For example, the Groenland, that is here, seems bigger as Africa when we know that actually Africa is 4 times bigger than Groenland. And this happens because the pole area on the sphere is smaller than the equatorial area, but has to be projected on the planar in a regular blocks. So it means that has to be stretched. So we have some artifacts are introduced in the image that we display at the pole area. And this happens also for the viewport projection. So when we need to evaluate the final quality at the user side, we need to figure out a new geometry-aware distortion matrix. In the literature, we can already find some solutions. So, for example, the very popular PSNR, that is the quality metric that it's used nowadays, it has developed in a spherical weighted PSNR. So, based on the viewport position inside the sphere, we can weight the distortion. The second challenge that I want to talk to you is about the storage. And I want to give you a possible strategy of solution that I'm working on now. So what we need to store at the server is it has to be limited because we don't have infinitive space, available space. And at the same time, the cost of storage and coding is high. So we need to find to minimize the number of representation of video to store at the server side. But at the same time, as I've already mentioned, we have different users that request this kind of content, and every user has a different path inside the video. So we need to find the best trade-off between the number of representation that has to be downloaded to accommodate different requests from users. The second challenge, the last challenge that is the most popular, is the streaming aspect. In this case, we want to improve the quality of experience of the user. That it means, for example, that we want to minimize the times of the freezing frame during the display of the video. So that it means that we need to deliver quickly the video at the user. At the same time, we need to send the entire video, but the user is displaying only a small portion that usually is around the 10% of the entire video. So obviously we are wasting bandwidth. In the literature, we can find already some solution. So some strategy to try to overcome this problem. The simplest one is the traditional streaming. So the 360-degree video is encoded entirely to uniform quality. And at the client side, we try to adapt the representation only based on the available bandwidth. But obviously in this case, if the bandwidth is decreasing, also the quality, obviously, of the video decreasing a lot because it's very huge bandwidth demanding, this kind of video. The second kind of solution that we can find in the literature is to send again the entire video, but this time is encoded with non-uniform quality. So at the server side, we have different representation with different quality center. That it means that the area around this center is at higher quality and the other part of the video is at lower quality. In this way, we can save bandwidth, obviously, but at the user side, we need to adapt not only in terms of available bandwidth, but also based on the user position. And finally, the last strategy is a tile-based system, where the video this time is split in more blocks, and each block is encoded independently. And obviously, at the server now, we can have a different representation of each block. And that it means that at the user side, we have more flexibility to adapt only the interested area, so the viewport at higher quality, and the rest of the video can be downloaded at lower quality. And in this case, we can really save bandwidth. And this last strategy is the most popular nowadays in terms of research. And also me, with my supervisor, Laura Toni, last year, we have presented at MMCP a navigation-aware adaptive streaming strategy for omnidirectional video. Our idea was to use a tile-based system, and we implement an optimization strategy at the client side that take into account the user probability to display different area of the sphere, plus a geometric-based distortion in order to have also the spherical new construction considered. To give you an idea of my work, I want to show you a simple video where here on the right we have the traditional streaming, so the video is full encoded at uniform quality, and on the second part we have our proposed solution where the quality is moving, the higher quality, the part at higher quality, sorry, is moving based on the user position inside the video. Okay, so as we have seen until now, it's the user that is the key factor that connected all these three different challenges. So the next step is to try to predict the user position inside the video. But before to go for a prediction algorithm, now we are trying to analyze some user behavior inside the video to try to figure out some patterns, some similarity between users. And what we are doing now is try to clusterize users in a different group based on their position on the sphere. We are trying to clusterize because we are convinced that users that are looking at the same area of the sphere can be deal with us the same way. So this can help in the adaptation logic at the client side. So here we can see some few simple results. I try to using a very simple clustering algorithm that is a key means algorithm, and it's based on a distance position. I implemented a new spherical key means algorithm where instead of the traditional Euclidean distance, it uses the geodesic distance. And here we can see, for example, the red line is the result in terms of space of clustering obtained with the spherical key means. So we can see that with this algorithm we can have a very small group, very small clusters. So we are able to really figure out which users are looking at the same portion of the sphere. The second step, once that we have finished with the analysis, will be to try to figure out some content feature related with the user behavior, and so propose a new head movement prediction algorithm to know in the future where the user is going to look at. So to summarize, we have seen that to optimize the 360-degree video streaming, we need to improve some aspects. So for example, we need to have a spherical distortion metric. We need to optimize the storage at the server side. We need a navigation-aware adaptive streaming at the client side that consider also the user behavior. And finally, we need to predict the user behavior during the navigation in an immersive video. Thank you for your attention.